Today, our report would be about the petrochemical industries. Now, our report would be split into two parts. First is for the oil and natural gas, while the second part is about plastics and resins. So the contents of our report would be about the brief background and history of the industry, major companies involved, common products in the industry, the process flow diagram, and the statistics involved in the industry. Let us now discuss the brief background and history of the petrochemical industry, starting first with the oil and gas. Petroleum fossil fuels are mixtures of hydrocarbons that formed from the remains of animals and plants that lived millions of years ago in a marine environment. Over millions of years, the remains of these organisms were covered by layers of sand, silt, and rock. Heat and pressure from these layers turned the remains into what is known as fossil fuels. Fossil fuels exist in liquid or gaseous form in underground reservoirs and in tiny spaces within sedimentary rocks near the Earth's surface. The liquid form, known as oil, is refined and used in a wide array of industries, such as power generation and vehicle fuel. On the other hand, the gaseous form is known as natural gas, which is mainly used in power generation and plastic manufacturing. Let us now go to the history of the industry of the oil and gas. So in the year 1847, Scottish chemist James Young observed natural petroleum seepage in the Readings coal mine, and from this seepage distilled both a light tin oil suitable for lamps and a thicker oil suitable for lubrication. In the year 1850, Young partnered with Edward Binney and formed the first truly commercial oil refinery in the oil works in the world, manufacturing oil and paraffin wax from locally mined coal. In the same year of 1850, Canadian geologist Abraham Gesner refined a liquid from coal, oil, shale, and bitumen that was cheaper and burned more cleanly than other oils. He dubbed this liquid kerosene. In the year 1854, Polish engineer Ignacy Lukasiewicz improved Gesner's method to easily distill kerosene and petroleum, and opened the first rock oil mine in Bobka, Poland. In the year 1857, the first oil well drilled was in the town of La Brea, Trinidad. It was drilled to a depth of 280 feet by the American Merrimack Company. In the year 1865, John D. Rockefeller founded the Standard Oil Company, becoming the world's first oil baron. Standard Oil quickly became the most profitable in Ohio, controlling about 90% of America's oil refining. In the year 1907, the discovery of oil in Masjid Suleiman, Iran, by William Knox DRC led to the incorporation of the Anglo-Persian Oil Company. The British government purchased 51% of the company to provide Navy with oil during World War I. In 1954, APOC became British Petroleum, known today as BP, which is currently the sixth largest oil and gas company in the world. In 1960, Iran, Iraq, Kuwait, Venezuela, and Saudi Arabia formed the Organization of the Petroleum Exporting Countries in response to multinational companies on the rise. So overall, today, OPEC has 15 member countries, accounting for approximately 44% of global oil production and 81.5% of the total oil reserves. The oil and gas industry is still thriving today despite competition from new renewable sources of energy, albeit in a more volatile state than ever due to world events.
For the major companies involved in petrochemicals industry, particularly for natural gas. The industry is a crucial, strategic, and fundamental sector because of its sector's relationship to each other. This close connection has cascading impacts on businesses and the whole economy. The sector, as seen in the figure, basically provides inputs to other key sectors of the economy, which in turn generate auxiliary and other support businesses. For example, for the upstream, the naphtha cracker utilizes in materials naphtha and LPG. And the naphtha cracker can be used as a raw material for polymerization plants in the midstream. And furthermore, the product produced can still be utilized in the downstream for plastic products manufacturers. Next, for the companies leading in the said industry, one is the Baden Aniline and Soda Factory, or BASF, which is a multinational chemical company. According to BASF, the petrochemical sector forms the backbone of the company's value-adding chain. Steam crackers generate ethylene, propylene, butadiene, and benzene from naphtha or natural gas at facilities the business has developed across the world. It has approximately 160 subsidiaries and joint ventures with clients in almost 200 countries, employing over 96,000 people globally. Locally, the Philippine petrochemical sector strives to secure and deliver the country's essential resin requirements in a competitive and efficient in order to catalyze sustainable and dynamic manufacturing activities that promote growth across all industries. In the local market, Petron Corporation, Shell Philippines, Chevron Malampaya, Macren International Ventures Incorporated, and NPC Alliance Corporation or NPCA are the most prominent companies in this industry. For the naphtha manufacturing, JG Summit Olefins Corporation or JGSOC owns and runs the country's first and only naphtha cracker facility, which generates the olefin raw materials, ethylene and propylene, as well as mixed C4 and pyrolysis gasoline, which are utilized as feedstock by JGSPC's polymer facilities.
Petrochemical industry is an essential part of the chemical industry since there is an increasing demand for synthetic materials in today's manufacturing sectors and economy. I am going to present to you some of the important and common products associated in this industry. First off is the benzene, a feedstock or a raw material found in crude oil that is partially responsible for the smell around gas stations. It is a colorless and flammable liquid that is used as a gasoline additive since it increases the octane rating and decreases the spark knocking in gasolines. Benzene is considered, however, as a carcinogen. That is why it is typically fully reacted in a closed system wherein only up to 0.62% benzene content remains in finished gasoline or petroleum products. Next off is the methane, an odorless and colorless flammable gas that, when burned, produces less carbon dioxide in comparison to other hydrocarbon fuels. It is a good source of hydrogen that is used in manufacturing ammonia for the production of fertilizers and explosives. It is also used in fuel production and is often included in rocket fuels. Last but not least is propane, a flammable byproduct of natural gas and petroleum refining that is commonly sold as fuel because of its low boiling point and high energy density. It can easily be transported, that is why it is commonly used in a lot of households, especially for leisure outdoor activities such as camping.
In here, we are going to discuss the process flow diagram of the petrochemical industry. Let's first start with the basic petrochemicals, which serves as the basis for many products of this industry, which will be further discussed in the next video. Let's start with olefins, including ethylene, propylene, and butadiene. The process begins with the cracking of the feedstock, which includes naphtha and natural gas, such as propane, ethane, and butane, forming ethylene and propylene. The temperature is at 500 to 800 degrees Celsius. The reaction is highly endothermic. It is then fed into a water-based quench for it to cool down and to avoid further reactions. Next is compression to prepare the gas for further separation. Together with compression, acid removal also occurs. So in here, we are trying to remove the sulfur from the cracked gas. Lastly is the separation to remove hydrocarbons and hydrogen from the pure ethylene and propylene. Inputs include naphtha, which is used for hydrocarbon cracking, and feedstock, of course, as mentioned. Lastly, catalyst. The catalyst that can be used here is zeolite or aluminous silicates. Byproducts are C4 and C5 products. Now, from C4, it can be further processed through extractive distillation to form butadiene. Next is methanol. The production of methanol begins with the removal of the sulfur from the natural gas, which is in the form of H2S. We can call it as the desulfurization of natural gas. It is then fed to a furnace where reforming occurs, forming syngas, which consists of carbon monoxide, carbon dioxide, H2O, and hydrogen. This can be done by catalytic reforming and combined reforming. The product syngas is then converted to methanol through the process called methanol synthesis. Lastly, the crude methanol will undergo distillation for it to be more concentrated and purified. Here is the summary of the processes in the methanol production, including desulfurization, syngas preparation, methanol synthesis, and distillation. Our inputs include natural gas and catalysts for the reaction to occur faster. Our byproducts include a toxic chemical called carbon monoxide.
For our third flow diagram, we have the aromatics, starting from petroleum or crude oil that was formed from the remains of marine organisms. It will undergo distillation, which is the process of separating components from a liquid mixture to distill off a suitable fraction rich in naphthalene that serves as precursors for aromatics. Next is catalytic reforming. This is a refining process that uses selected operating conditions and selected catalysts to convert. This is used to produce an aromatic gasoline. Catalytic reforming is a key conversion process in a petroleum and petrochemical industry. It gives flexibility to meet gasoline octave number requirement. It can also make aromatics of high market value. Next is fractionation. It is a separation of mixtures of liquids, then solvent extraction, or the process that separates compounds based on relative solubilities. This is to eliminate non-aromatic from aromatics. Next is distillation to produce pure benzene and toluene. Then distillation, aromatic C8, to yield by superfractionation ethylbenzene and O-xylene. Lastly, isomerization, or the process that rearranges hydrocarbon molecules into a more useful isomer. For the input, we have petroleum or crude oil, and its byproduct is non-aromatics.
The data shows the statistics about the global gas consumption trend at year 1990 to 2019. This statistics was made by Enerdata, which was from the Global Energy Statistical Yearbook 2020. This consumption continued to rise slower in 2019 with an additional of 2.6% compared to year 2018 with 5.1%. In the United States, the consumption grew by 3.1% in 2019 due to the low prices and new gas-fired capacity in the power sector. Meanwhile, in China, the economic slowdown and the relaxation of policy on coal to gas switching contributed to half the growth in gas consumption by 8.6%. 3.1% was consumed in Europe as demand recovered in Spain, Germany, and Italy, and also in producing countries such as Russia, Australia, Iran, Algeria, and Egypt. However, in Asia, this consumption continued to decline in Japan and in South Korea due to lower demand in the power sector. China, the economic slowdown and the relaxation of policy on coal to gas switching contributed to half the growth in gas consumption by 8.6%. 3.1% was consumed in Europe as demand recovered in Spain, Germany, and Italy, and also in producing countries such as Russia, Australia, Iran, Algeria, and Egypt. However, in Asia, this consumption continued to decline in Japan and in South Korea due to lower demand in the power sector. Gas consumption remains stable in Latin America with slight declines in Brazil and Argentina with a 4.4% growth in Mexico. For the production of natural gas, USA was the largest gas producer, accounted for over half of the 2019 global increase, followed by Russia, Australia, China, and Iran. US domestic gas production rose by more than 10%, triggered by new developments in shale formations in Texas and in Pennsylvania. Gas production also continued to rise steadily in Russia with 3.4% and in Australia with 18%, pushed by the development of LNG projects and by domestic demand. However, the production continues decreasing in Europe with negative 5.7% as maintenance and outages reduce input in Norway with 5.7% gas production. It also remained quite stable in Latin America despite a 5% increase in Argentina.